When considering the implementation of third dimension mobility solutions in cities, it's important to involve local authorities as key partners throughout the process. This includes developing the necessary infrastructure and technologies and ensuring public safety and acceptance. However, it's crucial also to address the challenges that local authorities may face in managing urban space. This involves typical concerns around innovation development and competency issues within various departments, monetary constraints, compliance with strategies and legal frameworks, and maintaining a positive public image. To prepare cities for urban air mobility, engaging with city residents and local authorities is essential to address these challenges and ensure a successful and sustainable integration of third dimension mobility solutions into urban transportation systems. Cities play a vital role in developing and implementing urban air mobility (UAM) services, which require proper organization, regulation, and supplementation with new services. As natural ambassadors of UAM, cities can effectively address the needs and concerns of residents while ensuring public safety. As entities responsible for their citizens, local authorities can co-create drone scenarios for urban services and act as potential co-owners of UAM infrastructure. They are also crucial partners in the multi-level management of urban space. Thus, the involvement of cities in the development of UAM is crucial for ensuring the success and safety of these innovative services. In implementing drone city services, it is worth directing efforts to include the public sector alongside the innovation market, as citizens' safety and comfort should be addressed. ASSURED-UAM project recommendations were developed with urban areas from Poland, Italy, and Portugal, chosen for their location, allowing cross-cutting data exchange and experience sharing. Bari and Porto are popular coastal tourist destinations, while GZM is located in an inland post-industrial area. Although GZM, an association of 41 cities and municipalities, is larger than the other two metropolitan areas with over 2 million inhabitants, Bari and Porto function as centers of polycentric urban systems whose populations exceed 1.2 and 1.7 million, respectively. All three areas are on major national transport routes, making them important for exchanging goods and services. A common specialization among them is the medical sector, reflected in the UAM services developed as part of the project. GZM, Bari, and Porto worked to implement UAM in their areas as part of the project, exchanging best practices and sharing experiences. They provided UAM tests and pilots, as well as activities to build public acceptance, including surveys involving stakeholders in the co-creation process. Partners conducted feasibility studies and partial recommendations. Together, they studied the potential of drones for delivery concerning residents' shopping habits. Bari focused on testing business cases and building awareness of the technology. Porto on modeling cargo logistics applications, and GZM on building awareness of stakeholders in the process, including municipal authorities based on the medical and environmental applications of drones over cities. The metropolises worked jointly and separately to provide input to project recommendations and involve stakeholders in the co-creation process. The project tasks were facilitated by the involvement of technological and R&D partners on the Bari and Porto sides. Distretto Tecnologico Aerospaziale SCARL and Centro di Engenharia e Desenvolvimento CEILA, respectively. Cities demonstrated UAM services to support recommendations including drone applications for road observation, multimodal delivery, precision door-to-door delivery, and advanced air mobility for medical emergencies. In Bari, drones were demonstrated at the Fiera del Levante in November 2022. In Porto, a cargo logistics network was modelled and added to the city's actions as a front-runner on UAM with the Free Zone for Technology project at Hospital de São João and its respective pilot in April 2022. GZM, in cooperation with the city of Sosnowiec, presented drone technology applications for local government tasks such as investigating landfills, monitoring river water levels, and searching for missing persons in December 2022. As mentioned before, urban air mobility implementation requires the active involvement of cities in the process. When starting it, it is important to remember that UAM will not necessarily be on the list of priorities of local authorities. In the case of GZM, involving city stakeholders in the identification of urban areas that might be affected by drones was an important first step. This process should include officials from various departments, such as infrastructure, environment, and development. By involving them in the process, the demonstration stage becomes easier, as it is based on the needs identified earlier. Through this process, officials become more aware of the potential benefits of drones in city services and are more likely to engage in subsequent activities. In the case of GZM, a drone prototyping school was established where 50 officials were trained in UAM, including theoretical issues, co-creation, and drone operation. These experiences highlight the importance of building awareness among public partners who, with knowledge and awareness, become more open to cooperation and inspire application scenarios aligned with the city's strategies and residents' needs. When implementing services of a new type, the voice of residents must not be forgotten. A survey was replicated by the 3 cities involved in the ASSURED-UAM project to assess the attitude of citizens towards the use of drones for cargo logistics. Results based on a sample of 925 respondents showed that citizens were experienced with online shopping, with about 45% buying at least once a month. The main reason for buying online was convenience, while the reasons for not shopping online are the preference for traditional stores and safety. Citizens buying online mainly acquire fashion products, technological items, books and cosmetics. There was not a significant difference in the online shopping patterns in the 3 regions. 56% of the citizens are unaware of using drones for city logistics, with Italians registering a higher knowledge about it. 68% consider drone delivery a plus, and 75% would use it if it would not have additional costs. 65% support public investment in UAM, and 69% claim they are ready for drones to fly over their homes. These optimistic values might be influenced by the fact citizens are providing an opinion about something they still do not see. Portuguese are ready to pay for it if it is more environmentally friendly, while Polish and Italian would do it for more flexible service. The 3 countries are quite optimistic about the expected benefits of drones, with most of them pointing to the decrease in congestion as a major effect, followed by the reduction in pollution. In Porto, it was carried out a feasibility study intended to quantify those benefits and assess the feasibility of using drones for cargo logistics in the city. The feasibility study was supported by a survey carried out along the project, and the quantification was performed with the help of traffic simulation. An air network was designed with assumptions based on the land use occupation, the area's topography, and vehicle dynamics based on real data. several scenarios of possible replacement of vans and trucks by cargo bikes and drones were tested. The best scenario for Porto's cargo logistics patterns would be the one equivalent for a service delivered by 95.5% of vans, 2% of cargo bikes, and 2.5% of drones. This means that it is only feasible to replace 4.5% of the conventional current vehicles with cargo bikes and drones to keep the same delivery service level, and, at the same time, guarantee that it would be possible to reach improvements in the traffic flow of the area, on CO2 emissions reduction, and on delay times. Such value is strongly linked to the intrinsic characteristics of the city, delivery patterns for the commercial areas, and respective time windows and physical constraints for the flight. When considering the mission profile for each of the paths of the network, and considering it is a network with a short distance range in the inner center, the air network can accommodate up to 0.33 drones per kilometer. This limitation comes from the air network that, in the short term, the number of drones flying over the city is such that it causes a very significant visual disturbance. The UAM model adopted should be based on the specific needs identified by cities, which can be commercial or public. GZM, Bari, and Porto have prioritized public applications, focusing on medical missions. Within this framework, GZM developed recommendations for medical transport in collaboration with various stakeholders, highlighting the need for cities to provide adequate IT resources, ensure social acceptance, and include UAM infrastructure in urban planning, or the need to work with air navigation service providers and aviation partners. Given the special nature of medical transport, attention was also given to container construction, transport condition monitoring, cargo damage prevention, visible marking, and ongoing maintenance to ensure maximum safety for medical cargo. The collaboration on recommendations with the medical community, emergency services, city authorities, R&D units, and UAV companies was crucial. Implementing urban air mobility, UAM, in cities requires building awareness among citizens and city officials and forming diverse partnerships. This facilitates the creation of socially relevant UAM scenarios within the framework of Sustainable Urban Mobility Plans, SUMP. Including UAM in a SUMP allows long-term thinking about new transportation methods and risk mitigation measures. The ASSURED-UAM project emphasizes the importance of involving officials from various departments in the UAM process to make demonstration stages easier and increase engagement in subsequent activities. Building awareness among the public allows for cooperation and inspires application scenarios aligned with the city's strategies and residents' needs. A control room, vertiports, sandbox, ground, and air consideration risk must be built to ensure safety in aerial activities. Demonstrating UAM capabilities and services in real-world settings is the best way to introduce the UAM ecosystem to a broad audience. Enterprises involved in building UAM ecosystems should also realize the importance of events to popularize UAM issues among citizens and demonstrate challenging, successful use cases. However, developing risk mitigation measures is costly, time-consuming, and labor-intensive, requiring technological and legislative advancements for faster and more effective deployment of UAM services.